In this tutorial, you'll learn about scatter plots. Pictured here in the center is an example of what a scatter plot looks like. It's a bunch of points scattered around a coordinate grid. Now sometimes when you scatter these plots, they make a pattern. And that's what we're going to talk about today. So here are some things you need to know about scatter plots. When you plot the data, it doesn't always lie on a perfectly straight line. Sometimes they're scattered around the plot. But they always compare or relate two sets of data. The data is plotted as ordered pairs, and then those points that are scattered around the plot are used to investigate a correlation or an association between the two quantities. These are the three types of correlations you will commonly see. Sometimes they're referred to as an association, but those two words are synonyms. So as you can see here in the first example, my red dots that are scattered along the graph are moving sort of in an upwards fashion. So as you read a graph from left to right, that's how we read our graph. As we read our graph from left to right, our eyes move in an upward position. Sort of like as if we had a line, it would have a positive slope. So we call this a positive correlation. As we read the middle graph, our eyes trend downward. So we call that a negative correlation. And if as you're reading the graph from left to right, the points are scattered all the way up and down, we call this no correlation. Now as you read from left to right, you follow the general path of the points. Sometimes you have maybe you have one or 2 points that kind of are lying farther away from the data. We call that an outlier. And we really don't take that into consideration when we're determining the overall trend of the data. Remember, the trend of the data is how your eyes are moving as you read the graph from left to right. These are some special examples where it's really hard to tell if the trend is positive or negative. So if you have some plots scattered around, and they're generally moving both upward and downward, we say that they have no correlation. And the same is true for this horizontal pattern. You can't really say if it's moving upward or downward, because if I ask you to predict some more points as we move along from left to right, they could be here, they could be there. All of them would make sense and follow the pattern, but we don't necessarily know if it's going to be above or below that line. And this one, you couldn't really draw a line through the data and make any meaning at all. So that's definitely no correlation or no association. In addition to scatter plots moving in a positive or negative trend, they also can be what we call linear, following along a straight line path, even though they're not perfectly straight, or we could say that they're more along a curved path, which we call nonlinear. And if they're scattered around all over the place, we simply say they have no relationship or no correlation at all. So sometimes we describe it as positive and we describe it as linear at the same time. Now, it's not perfectly linear, but it is linear-ish. All right. I think it's time for you to give these a try. Look at these 6 examples and pause the video and see if you can identify whether they have a positive correlation, a negative correlation, or no correlation. All right, did you write down your 6 answers? Let's take a look and see how you did. Great. Next, I'm going to show you a sample of a text question. As the age of a car increases, its value decreases. So as we read from left to right, the age of the car is increasing, right? That's what happens when you read the X number line from left to right. So the question is, which one would show that the value of car is decreasing over time? So as I read from left to right, that's definitely called increasing. But what's happening with the scatter plot? So if the value of the car needs to be decreasing, that would be choice B. All right, take a look at this scatter plot from the title screen. What do you notice about these points scattered around? Are you noticing a trend? Can you interpret what all of this data means? Hopefully you're noticing that the trend is moving downward, or in a negative correlation. Now, when we interpret the data, we use the words along the labels of the axes to really describe what's going on in this situation. Sometimes it's best to kind of draw an imaginary line on your graph to help you identify the trend. Now remember, as you're reading along the graph, the x values are always increasing. So it looks as if, as your age increases, your heart rate, or your beats per minute, starts to decrease. That's called interpreting the data. Some might even summarize it as the older you get, the slower your heart beats. All right, sometimes when we have data, we will draw an imaginary line that we make up ourselves. It's called a line of best fit. And you generally want your line to go through the center of your data. It doesn't necessarily need to touch any points at all, but it should be centered through the middle of the trend. It's called a line of best fit. Here's some examples of an imaginary line of best fit that are drawn on some scatter plots. When you draw a line of best fit, it helps you to make predictions. So some people call it a prediction line or a regression line. And don't forget, it goes through the middle of the data. It doesn't have to go through any points in particular. So you can kind of look at this one on the left. It almost doesn't touch any points at all. But most of the points are evenly scattered. Some are above the line, some are below the line. And that's what's important about having a good line of best fit. If you have to construct one yourself, oftentimes we recommend drawing an oval around your data and then finding the midpoints of that oval to help you construct your own line of best fit. Here's some examples of some good fit and poor fits. Now hopefully they're really sticking out to you as, wow, that line doesn't really follow the direction of the points. This one on the end here can be a little confusing for students because the line does follow the direction, but it's not really centered throughout the data. Some of the data points should fall above the line and some of the data points should fall below the line. Why don't you pause the video and assess these lines of best fit? All right, let's see how you did. So we got 2 good fits and 2 poor fits. Awesome. Here's an example of a test question where you are asked to apply some of your other prior knowledge into this new topic of scatterplots. So this says the scatter plot below shows the numbers of customers in a restaurant for 4 hours of the dinner service on 2 different Saturday nights. The line shown models this relationship, and when x equals 0, that represents 7 p.m. So the question is, what does the value of the Y-intercept represent? So don't forget the Y-intercept is where you touch the Y-axis, right? Where you cross over the Y-axis. So right now, it looks like it represents 0 on the x-coordinate and about 50 on the y-coordinate. So what they want you to do is find meaning and context. What does that 0 mean? And if we look up at our clue here, the 0 means it's 7 p.m. So the 1 would mean it's 8 p.m., the 2 is 9 p.m., 10 p.m., 11 p.m., etc. So what does the value of the Y-intercept represent? It represents the average number of customers at 7 p.m., the starting value. All right, let's take a look at another real-life graph. Again, scatter plots don't fall on a perfectly straight line, but they do generally have a pattern which will help you to determine some type of relationship between the two sets of data. So this one has a set of data of fat grams in a restaurant sandwich and the amount of calories. So let's see if we can't make some sense about this graph. So in looking at this restaurant sandwich scatter plot, what conclusion can you draw about the relationship between the amount of fat grams a sandwich has and the amount of calories it has? Pause the video and write down a sentence or two. All right. As I read my graph from left to right, I can see that my eyeball trends upwards. If I were to draw a line of best fit, I could see that it would generally pass through this area here. So it looks like as the fat grams are increasing, the calories are also increasing. So that's a conclusion I can draw. The more fat grams you have, the more calories your sandwich has. Here's a helpful hint. Every time you want to describe a graph, you always start with this sentence. Because you read a graph from left to right, and when you read the X number line from left to right, the numbers are always increasing. So no matter what you're describing, it will always start with this phrase, as X increases. Now I put those X in quotation marks because generally, instead of the letter X for the axis, we use the label from the diagram. So if I were to start describing this graph, I would start by saying, as the fat grams increase, and then instead of the letter Y, I would use the label from the Y-axis. So as the fat grams increase, the calories also increase. How about this one? Do you think you can come up with a sentence using the words from the labels? Give it a try. Don't forget my sentence starter from the last screen. Pause the video now. All right, let's see how you did. My sentence was, as the temperature increases, ice cream sales also increase. Somebody else might say, the warmer it gets, the more ice cream that's sold. All right, let's take a look at a couple test prep questions. Sometimes when you have a scatter plot, you're asked to make some predictions, and that's when a line of best fit sure can come in handy. Based on these results, if a team practices 4 hours per week next season, which is the best estimate of the number of debates the team can expect to win? Based on these results, if the team practices 4 hours, how many debates can we expect to win? Well, I see a plot point here that's already for 4 hours a week. So if I'm going to make an estimate based on my imaginary prediction line here, I might say that they could probably win about 16. You see how my line of best fit is my prediction line? And that's why I'm going to choose this value. 20 would be too high, 12 would be too low, and 1 is way down here. Let's take a look at another question. Based on the data, which best represents the amount of money the carpenter would earn from a job that took 5 days to complete? Well, if I'm using a line of best fit, right, and you could sketch it more than once, right? You don't have to pass through all the points, but you certainly don't want a line of best fit way up here. So my line of best fit here is going to help me predict that if I have a job for 5 days, probably be about $1,250. All right, the last thing you need to know about some scatter plots is not only can you describe the trend and the shape, which we already discussed, but you can also describe some oddities. They're called outliers, gaps, or clusters. So here's an example of how they look. We kind of saw this on the first page. An outlier is a point that's located away from the rest of the data. A cluster is a close grouping, right? See how these are more spread out and these are really tight knit together? And a gap is an open area with no data points at all. So that pretty much concludes everything that you need to know about scatter plots. The only other thing you could be asked to do is to take data and plot it yourself, and then analyze it using the techniques I showed you in this video. If you don't know how to answer a question like this, be sure to ask your teacher for some extra review. And that concludes the tutorial on scatterplots.